10.5a. All right, we're going to do our fourth and final conic section, which is hyperbolas. People want to call them hyperbolas, but that would be wrong. Hyperbolas, yeah. All right, so we have two parts today. I'm going to first do a little introduction into what a hyperbola is, and then we will do some examples. Okay, same thing though. It's either here's the equation, tell me what all the stuff is, or here's some stuff, give me the equation. All right, now there's two types. We're going to have two types of hyperbolas, okay? So hyperbola number one, it looks like this. X squared over a squared. So far it looks like an ellipse, but it's going to have one teeny little thing that's going to affect it greatly. Minus y squared over b squared equals 1. Okay? All right, so let me tell you what all this stuff is. Oh, and then the other one is going to be y squared over b squared minus x squared over a squared equals 1. Because subtraction isn't commutative. In other words, 5 minus 3 is not 3 minus 5. So these make a difference if x is minus y or if y is minus x. It makes a huge difference. So let's talk about their differences and all their pieces. All right, here we go. This is what you're going to do to graph a hyperbola. It's going to feel a lot like an ellipse, but then you're going to turn it out. Isn't that fun? It sounds fun, right? Here we go.
Yeah, that sounds like that one.
Yes, yes. We're going to go all the way to A, both left and right, just like an ellipse. What we're going to do is we're going to put a point there. And those are our vertices. Now, be careful. We're going to go a distance of b in each direction, but there isn't a point there. Well, then why do we need that? This is what you're going to do. You are going to draw a rectangle through A and B. Okay? So your rectangle is going to look like this. Like this. This is not part of the graph. It's just to help you to graph it correctly. All right. Now, we just drew a rectangle, and then through those rectangles, we're going to draw asymptotes. The asymptotes are going to go through the origin and through each corner of the rectangle. Okay? Still, not part of the graph. The only thing that we have graphed on this graph are those two dots, and that's it. Okay, now here's how you graph hyperbola. You're going to take it and you're going to go right along the asymptote. It's going to go through that point there that we plotted, and it's going to do that. Okay? So the only part that I've graphed, all the rest of it is to help me graph, but this is the only part actually on the graph, these two things. I'll draw them in yellow. It's just this and this. Okay? Are those functions? Is that a function, by the way? No, it's not. It's not a function. Okay, so let's talk about all the pieces now. Let's talk about all the pieces of this hyperbola. This hyperbola has vertices. It does not have co-vertices. Okay? The vertices are these points because x went first. The vertices are at plus or minus a0. It doesn't matter which one's bigger, A or B. That's ellipses. That's totally different. It matters which one came first in your equation. Okay? Yeah, the A came first. It was x squared over a squared. Those are your vertices. The other thing is you have x intercepts of this graph. Excuse me. Like choked on nothing. Okay. The x-intercepts are also at plus or minus a. The y-intercepts of this graph, does this graph ever touch the y-axis? When you look at it, the graph is just the yellow part, okay? No, it doesn't. So there's none. There's no y-intercepts at all. Okay. And then the foci, this is also going to have foci. And so I think of it like this. So here's an ellipse. It looks like this. It comes together. It's a plus, like bring it together. And the foci are inside. But once the hyperbola minuses, everything gets flipped out. And not only that, but also your foci get flipped out so that they're inside the bowl of it. Okay? I'm going to draw them in green. This right here, foci 1, foci 2. And this distance from the center, that distance there is C. So the foci would be at plus or minus C0. Okay? All right, let's go over to the other side, and I'm going to give you the foci equation in just a minute. But let's go to this side and let's do this one now. Let's see how this changes things over here. So if I have y squared over b squared minus x squared over a squared, and I want to graph that. I look at that b, and I'm going to go up and down a distance of b, and those are going to be my vertices. Okay? Those are my actual points on the graph. Bless you. Then I'm going to go distance of A left and right, and A could be bigger than B or B bigger than A. It doesn't matter. So whichever one comes first. And then I draw this rectangle. Okay, you have to draw the rectangle. I need to see that on your graphs. And then you want to draw the asymptotes. And the asymptotes are the diagonals that go through the corner of the rectangle and through the origin. Okay? And then you draw your graph. Now, if y is first minus the x squared, then your graph is going to go up and down. It goes through b and through negative b on the y-axis. It goes actually through those points, and that's what the graph looks like. I'll draw it in yellow. I know there's a lot going on here. There's a rectangle, there's asymptotes, but the graph is simply just the yellow part, going up and down because y is first. So then just like this one over here, we're going to have a whole bunch of pieces of information. So now what are the vertices? Since y is first, my vertices will change. Instead of plus or minus A0, they are now 0 plus or minus B. They're right here and right here. Those are the vertices. Okay? The x-intercepts. Does this graph ever cross the x-axis? Does the yellow touch the x-axis? No. Not at all. There would be none. And then the foci. I'll plot those in green. Foci are going to be inside the bowl, and that distance there from the center to the foci is C, so your foci are at 0 plus or minus C. Whew, that's a lot, huh?
There's no y.
Oh, oh no, y-intercept, sorry. Y-intercept, the y-intercepts are at plus or minus B. Thank you, I missed that. Right here and right there. They touch the y-axis. Okay, 2 last formulas. Here's the last thing. To find the foci, do you remember how the ellipse foci equation is c squared equals a squared minus b squared? It's going to be the opposite. It's going to be c squared equals a squared plus b squared. And this is what I like to tell students. I like to tell them this. If your original equation has a minus, then your foci equation will have a plus. And if your original equation has a plus, that's an ellipse, your foci equation would have a minus. It's just opposites, okay? All right, and that's it. You don't have to worry about which one's bigger because it's plus. It's actually much nicer. And then finally, the last equation is for asymptotes. Last equation? I said last 2. I really did. Our asymptotes have an equation to them. They are these diagonal lines here. This is their equation. Y equals plus or minus B over A times X. Now, for those of you who are stinking tired of all these things that you're trying to memorize, it's actually not that bad. All you do is this. From the center, you count the rise, which is the B. You know rise. And then you count the A, which is the run. Okay? So all it is y equals plus or minus bx. It's like the slope, rise over run. Okay? That's all it is. Are you ready to do some? We're so ready. Now these are going to have a lot of points to these. Okay? So let's do part B now, and let's do some examples.
Is there only A and B today?
Yeah. Yep. And I think, yeah. Do I do all the examples? All right, we're only doing one of the types of examples, okay? I'm just going to give you the equation, and we're going to find all the stuff. Tomorrow, I'll give you some parts, and we'll find the equation. All right, number 1. Here we go. I've got like 3 of these. We'll try. Just 3. Okay, suppose I have x squared over 36 minus y squared over 100 equals 1. All right, and here's what we're going to do. We are going to graph it. We're going to find the, I know. Sometimes they'll ask you for the center. Right now, the center is at the origin, so that everyone should get that right. Center, vertices, foci, and asymptotes. Okay? It's going to be like a 5 or 6 point problem. It's a lot. There's so much to these things that there's a lot of points involved. All right, so you guys ready? Write that down. I'll let you catch up a minute. So here we go. It doesn't matter which one's bigger, okay? Don't think of that. I know it's hard to not because we just did ellipses and it was all about whichever one's the biggest one. No, this is whichever one comes first. And right now it's x squared minus y squared. So we're going to go a distance of 1, 2, 3, 4, 5, 6 in each direction. Left and right, okay? And those are our vertices. So the center, of course, right now is at the origin. We're going to move it on the block day. And then the vertices are at plus or minus 6, 0. Okay. Now let's continue to graph this. I also need to go up and down a distance of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I don't want to put a point there because there actually is not a point there. It actually just is going to help us in order to graph this thing. Okay, so I'm going to graph this part in red just because it's not really part of it. But here's the rectangle that you need to draw. The rectangle goes through 6 and negative 6 on the x and through 10 and negative 10 on the y. Okay, you draw that. And then you can draw your asymptotes in. Here we go. There we go. Don't make them too thick. All right. Classic. Okay, and then we can draw our graph. So here's our graph. Make sure you go through that point that you graphed for yourself, that point at 6, 0. And it's going to be kind of a wider one. It's going to open up pretty wide like this. It goes right along those asymptotes. Okay, over here too. It has both sides. It goes through negative 6 on the x. It's a pretty open one, and that's the graph of it. Aren't these fun? Just say yes. Okay, now we want to find out what the foci are. So the foci are going to be points somewhere in here and somewhere over here. And the foci equation is C is this distance all the way out to the foci. Okay? So for the foci, we're going to do c squared equals a squared plus b squared. So in the equation here, it's minus for hyperbola, but in the foci, it's plus. It's the opposite for ellipses. All right, so we get c squared equals 136. So c is plus or minus rad 136. Now, I do need you to rationalize that. Pause this. All right, so 136, then that would be 4 times 34. C equals plus or minus 2 rad 34. Okay, now make sure that when you go up here to your foci, you list this as a point. 2 points, actually. But you give it an x and you give it a y. So in this case, my foci are on the x-axis. So this would be plus or minus 2 rad 34. I didn't give myself enough room. Comma 0. Okay? Plus or minus 2 rad 34, comma 0. And now the asymptotes are going to be y equals, and there's 2 of them. Do you see how there's 2 of them? These red lines that go here and here. So plus or minus, because there's a positive slope and there's a negative slope. And what is the slope? You rise 10. Slope is to rise 10 and run 6. So that would be 5/3. So plus or minus 5/3 x. And that would be the asymptote equation. Okay? Whew, it's a lot, isn't it? Yeah.
For one.
All right, for one problem, I know. I think I only assigned 6 problems tonight, though. Yeah, just 6. But they take a while, right? It's like all these different parts to them. Yeah. All right, you know what I'm going to do next, right? We're going to do an up and down one, right? We did a side-to-side one. Let's go ahead and do an up and down one. So let's do y squared over 9 minus x squared over 25 equals 1. Okay, once again, it doesn't matter which one's bigger, 9 or 25. It matters which one comes first. So I always plot it like that. All right, so let's go ahead and list all the things that we need. We need the center, vertices, foci, asymptotes. Okay, asymptotes. All right. Center, once again, pretty basic, 0, 0, super easy, 0, 0. Okay, so look at the equation. It's y squared over 9 minus x squared over 25. So I'm going to go a distance of 3 in each direction on the y-axis. Because it's y squared over 9. So y, square root, up and down 3. Those are my vertices. Now be careful. People make this mistake all the time. They're like, okay, it's plus or minus 3, 0. But it's not. What are those points? 0 plus or minus 3. I know. Everything's going in the y spot because y is first. All right, then I'm going to count 5 in each direction, left and right. And then I'm going to draw this rectangle. I think hyperbolas are my favorite. I know I'm not supposed to have favorites, but, you know, definitely not parabolas, that's for sure, right? All right, so then I draw my asymptotes. My graph's a little off, but that's okay. So am I. All right, here we go. So then go ahead and go through those vertices and draw the graph going up and down. Those aren't what's it called? Functions either. They don't pass the vertical line test. Yeah, they're not.
Mother function.
All right, that was close. Okay, so c squared equals, now I'm doing the foci. The foci always goes with the foci equation. C squared equals, and it doesn't matter which one's first because it's plus. So c squared equals 34. So then c would equal plus or minus rad 34. I don't believe there's a perfect square in 34. Nope, there isn't. Okay. So now let's go ahead and write it in our foci points. The foci, as you can see, are going to be a distance away from the center. There's going to be a foci here and a foci there. And they're a distance of rad 3. That's what this green is, here to here and there to there, rad 3 over 4. So this would be 0 plus or minus rad 34. All right, how about those asymptotes? Y equals plus and minus rise over run x. The rise is 3 and the run is 5. Do you see that? You can even look at your graph. 3/5. Rise 3, run 5. So y equals plus or minus 3 over 5x. That's it. All right. I did say the last one, but you know what? I think I'm going to be okay with this with you guys. But if you get something that looks like this, just like you did in the ellipse homework, just divide everything by whatever that constant is on the end, and then you'll get it into normal ellipse form. So for this, I would start by dividing everybody by 64. And I would get x squared over 16 minus y squared over 4 equals 1, and then I'd go from there. Okay? So I gave you one of each. You're going to practice them tonight.